This is the Bering Strait. Temperatures hit 50 below zero as we prepare to connect America and Russia together. 55 miles of moving ice divide the continents. No one has ever closed that distance. First, icebreakers smash open a corridor for our logistics fleet moving across the locked frozen ocean below surface. Relentless ice keeps shifting, destroying everything standing in its way. Ports are impossible to use here. All supplies must arrive by air to build the first camps directly on ice. Managing logistics here is tougher than a moon mission. If heating stops, everything freezes within minutes. Modular camps keep thousands of engineers alive, including many African-American men working and living on the frozen sea. Ahead of construction, engineers must look downward first. Beneath us, the seafloor lies unknown, unstable. Engineers employ sonic drills to chart bedrock layers beneath silt, identifying secure anchoring locations below surface. Each weld must be flawless. Under extreme cold, steel turns fragile and may fracture like glass. Manufacturing was moved directly onto the strait. Floating barges now produce the concrete required for the foundations. This steel is highly specialized, a cryogenic alloy engineered to resist cracking as temperatures rapidly drop. The ice is deliberately reinforced to withstand trucks transporting hundreds of tons of heavy construction materials. The island at the center will function as the main anchoring point for the entire bridge structure. Crews carve a flat staging platform directly into the island's solid granite bedrock. The Arctic Titan crane is brought in. Capable of lifting 5,000 tons, it becomes essential for the next phase. Rigging setup alone requires days of work, while crews battle relentless, biting Arctic winds. Up here, the view is insane, but one wrong move in this wind could turn deadly fast. Work runs non-stop. During the endless winter darkness, the strait is illuminated by massive artificial suns. Nature is our biggest enemy. When storms hit, all work has to stop immediately. This ice sheet behaves like a living thing. Stress fractures are constantly monitored to stop the camp being swallowed. Constant maintenance is required since hydraulic fluid thickens into jelly whenever the heating systems fail. Holding this channel open means icebreakers must travel back and forth non-stop without pause. Foundation templates are set in place. Now the most dangerous stage of construction begins. We are moments away from lowering the first foundation. It must settle perfectly 50 meters below in total darkness. Under immense load, the crane holds 5,000 tons of steel hanging suspended above the water. The structure starts descending toward the seafloor, guided by sonar systems and underwater robotic teams. The first permanent structure of the Bering Strait Bridge is now in place. Now that the template is secured, crews can start pouring the bridge's permanent foundations. Massive steel piles are driven 30 meters into solid rock beneath the seafloor to ensure stability. Driving these piles takes such force that the surrounding ice trembles for miles in every direction. A specialized underwater concrete mix is used that hardens reliably even in near-freezing water temperatures. As the concrete sets, it pushes water aside, forming a solid rock anchor fused directly to the seabed. This concrete heats as it cures, so active cooling is needed to stop cracking in the freezing water. Rising above the surface, the first pier emerges. It now needs heavy armor to withstand the winter ice pack. Designed like knife blades, the piers slice through incoming ice flows instead of absorbing their full impact. Engineered this way, the structure redirects crushing ice forces upward and around, instead of absorbing direct impact. Protective armor plating is added to the concrete since the ice here can grind down exposed cement. One at a time, the foundations rise, forming a stepping stone path across the gap between continents. Here, the upward climb begins, using slip-form methods to raise the giant towers steadily without stopping. All the way up the tower, the concrete has to stay heated or it will freeze solid inside the pumps. We are climbing higher every minute. Fresh concrete is setting just below us. We have passed 100 meters above the ice. The wind feels like minus 70. The higher we go, the harder it becomes to work. Steam rises as the concrete cures in the freezing air. We are now at 200 meters. Crews bolt massive steel braces into place. Every joint must survive violent Arctic winds. The first tower has reached full height. The tower stands alone in the frozen wilderness. The saddle at the top will carry the main suspension cables. On the far side of the strait, another team is rising at the same pace. The two sides are moving toward each other. This bridge is being built together. The central tower rises from solid rock on the island. Engineers drill deep into the granite to secure the anchors. This will be the strongest point of the entire span. The towers are built to bend during storms without breaking. Sensors inside the steel track every movement. The vertical phase is complete. Now the gap between the towers must be closed with cables. This is the most dangerous phase. The gap between the towers is wide and the wind is brutal. A drone is flying a thin pilot wire across the span right now. That small wire will pull the massive cables into place. Everything starts with this fragile line. The spinning machines move back and forth non-stop. Each pass adds more steel wire to the main cable. Workers high above the sea guide every strand into place. It will take months to complete just one cable. Thousands of wires are bundled together into one giant cable. Crews tighten and compress the steel until it acts as a single solid unit. This cable is strong enough to carry enormous weight. It becomes the backbone of the bridge. Vertical suspender ropes are now hanging from the main cable. The web of steel is complete. The shape of the bridge finally appears against the Arctic sky. It dominates the frozen horizon. Now the road deck must be lifted into place. Each steel section weighs thousands of tons. Cranes move slowly and precisely in the freezing wind. Workers wait high above to guide the section into position. I am standing on the first section of the road deck. We are nearly 300 meters above the ice. The wind is hitting the steel around me, but this structure feels solid. This is the first piece of roadway hanging between two continents. Section by section, the road deck extends outward from the towers. Each piece must align perfectly before welding. Automated systems seal the joints with precision. The gap over open water is slowly disappearing. The final central section is lifted into place. Two sides meet for the first time. Steel touches steel above the frozen strait. The bridge is physically connected from one continent to the other. But vehicles cannot drive on an open deck in this wind. The roadway must be protected. Steel ribs are installed over the deck to form the frame of a tunnel. The bridge begins to take on a new shape. Panels of triple-layered heated glass are installed over the ribs. The enclosure seals the deck from the wind. Inside, it becomes calm and quiet. The bridge transforms into a protected passage across the Arctic. I am walking inside the enclosed section now. The wind noise is gone. Outside, the storm is still raging against the glass. But in here, it feels controlled and safe. This tunnel makes high-speed travel possible. A special asphalt mix is laid across the deck. The surface must handle extreme cold and high-speed traffic. Crews spread and smooth the material carefully. Road markings are applied with precision. Thousands of LED lights are installed along the tunnel ceiling. Ventilation systems are mounted to move fresh air through the structure. Every system is monitored from a central control room. Safety is the highest priority. Engineers watch the bridge from the control room. Wind and stress data update every second. Below the road, crews install rail tracks. Heavy trucks cross for final load tests. Camps are removed. Icebreakers make a final pass. The bridge is ready. The gates open. Vehicles enter the tunnel. Inside is calm while storms hit the glass outside. The midpoint tower passes overhead. In under an hour, the crossing is complete. Two continents are now connected. Thank you for watching.